If it is only prediction, then why there are so much hype? Prediction is not thinking, but prediction is one of the main component of thinking, and AI is doing it more accurately. How accurate it is? Let's explore. I'm going to tell you three cases. By the end, you will understand how accurately AI can able to predict. Case number one, language translation. Before AI to build a language translation app, company has to hire a linguist who is expert in multiple language. They write a grammar rules and programmer would convert those rules into code. For example, if this comes, translate it into this, like that. The problem here is language is too complex. For example, translating between English and Tamil is not just word by word translation. You need to swap the order of nouns and adjectives most of the times to make it readable. Before 2016, Google Translation app was rule based. Often you might experience inaccurate translation. In 2016, Google integrated deep learning AI into Google Translate and translation quality improved dramatically. For example, when translating from Tamil to English, it no longer translates word by word. Instead, it looks at whole sentence and predict the order and phrase that match English. It simply take the data from one language and predicted the correct set of words in right order. Its accuracy in predicting the order and words is what makes translation sounds natural. More we use, more data it collects and more it learns, and it becomes better. Case number two. Credit card transactions are one of the areas where prediction has traditionally been used to detect fraudulent activity. In the late 1990s, before modern AI, fraud detection relied on rule-based system and basic statistics. These systems worked by 80% accuracy, which means for 10 lakh transaction, 2 lakhs mistakes might occur, which is huge, right? In 2000, with the help of advanced statistical model, prediction accuracy increased from 85% to 90%. After the use of AI prediction, accuracy improved from 98% to 99.9%. So far, we see this in accuracy. Let's see this in different perspective, error reduction perspective. So before AI, improvement from 85% to 90% accuracy, meaning error dropped from 15% to 10%, which is error cut by one third. After the use of AI, accuracy improved from 98% to 99.9%, reducing error from 2% to as low as 0.1%, that is 20 times error reduction. AI-based prediction is promising. It reduces error by 20 times. Even it seems to be a small improvement, it matters when mistakes are too costly. Case 3. Predicting the object in an image. Predicting objects in an image may not seem difficult for humans, but do you know, even human makes error around 5% of the time. Fei Fei Li. She was a researcher at Stanford University. She asked a simple question: how can we teach computers to see? So she and her Stanford team built something massive. A huge dataset contains a millions of images with labels like cats and dogs, etc. Basically, massive organized collections of photos. They call it as ImageNet. Then she launched an open challenge: make computer recognize the images in ImageNet. This competition held between 2010 to 2017. The benchmark was human error, 5% error rate. In 2010, best machine made about 28% error. In 2012, massive breakthrough happened. Contestant used deep learning for the first time and the error dropped to around 16%. Computer scientist Hoglaw noted it was also a proof of concept for deep learning model which had been around for decades. After that, algorithm improved very fast. In 2015, one team beats human benchmark, 5% benchmark. In 2017, more than 30 teams performed better than human benchmark, more than 30 teams. We have shown three cases that proves how prediction accuracy has improved. We have already started using prediction in areas where it was not used before, like image recognition, language translation, but if you look at the real world, prediction is everywhere. From business decisions to daily activities, prediction is everywhere. As prediction becomes cheaper and more accurate, its impact becomes remarkable.